Hello everyone, welcome to the signal system class. In the previous class, we discussed the Mason's gain formula for finding the overall gain of any given system with the help of signal flow graph. Today, we will take an example and we will see how we can find out the overall gain of the given signal flow graph with the help of Mason's gain formula. Now, as you see that we have taken an example whose signal flow graph is given and we have to find out the overall gain of this signal flow graph using Mason's gain formula. Now, we know that according to Mason's gain formula, the overall gain is given by the expression C by R is equal to summation Pk delta K divided by delta. Since in the given signal flow graph the output is x5 and the input is x1, so we can write x5 by x1 will be equal to summation Pk delta K divided by delta. So first we will have to find out the value of Pk, delta K and delta. Now we know that the term Pk denotes the gain of the kth forward path. So first we will find out the total number of forward paths in this given signal flow graph. If we see this signal flow graph, we find that there is one forward path from x1 to x2 to x3 to x4 to x5. So this is the forward path, first forward path, and again we find that there is another forward path which goes from x1 to x2 to x3 to x5. So this is second forward path. This one is the first forward path and this is the second forward path. So the term summation Pk delta K will be equal to, so the term Pk delta K will be equal to P1 into delta 1 plus P2 into delta 2, because there are only two forward paths. So we will get only two terms. Now we will find the total number of loops present in this graph. When we examine the given signal flow graph, we find that we have a loop, this one, which is the self loop. The gain of this self loop is A44. Similarly, this is again a loop. The gain of this loop will be A23 into A34 into A42. This is again a loop and the gain of this loop will be A23 into A32. Now we find that this is also a loop and the gain of this loop will be equal to A23, A34, A45 and A52. Similarly, we find that there is again one loop, which is this one is again a loop. So we find that in this given signal flow graph there are total 5 number of loops. This is the first loop, this is the second loop, this is the third loop, this one is the fourth loop and this one is the fifth loop. So the term L1 will consist of 5 terms, because L1 is the sum of the products of the loop gains of all the loops. Now we find that the first forward path touches all the loops. First forward path touches all the 5 loops. So the value of delta 1 will be equal to 1, because the first forward path touches all the loops. As far as this second forward path is related, we find that the second forward path does not touch this loop. The second forward path does not touch this self loop whose gain is A44. So, the value of delta 2 will be given by 1 minus A44. The value of P1 will be equal to the gain of the first forward path, that will be equal to A12, A23, A34 and A45, and the value of delta 1 will be equal to 1 because the first forward path touches all the 5 loops. Similarly, the value of the P2 will be the gain of the second forward path, that will be equal to A12 into A23 into A35, and we find that since the second forward path does not touch the self loop whose gain is A44, so the value of delta 2 will be 1 minus A44. Why? Because the second forward path does not touch the self loop whose gain or transmittance is A44. Now we will find the value of delta. The value of delta in this case will be given by 1 minus summation L1 plus summation L2. Why only till L2? Because there are only 2 loops in this case which are non-touching. There are no 3 loops which are non-touching, so we will not get a term L3 in this case. So, if we see in this figure, we find that this loop and this loop are non-touching loops. This loop and this loop are non-touching loops. Similarly, this loop and this loop are also non-touching loops. So, now we will substitute the value of delta in the given expression. The value of summation L1 will be equal to the sum of the product of the loop gains. Since there are 5 loops, so we will get 5 terms. We will get 5 terms, 1, 2, 3, 4, 5. These are the loop gains of each loop. Similarly, L2 will be the product of the loop gains of 2 non-touching loops taken at 2 at a time. Since we have 2 pair of loops which are non-touching, so we will multiply the loop gains of 2 non-touching loops. We find that the loop A23, A32 does not touch A44, so we will take the product of these 2 loops. Again we find that the loop whose gain is A23 into A35 into A52 doesn't touches the self loop, so we will again take the product of these 2 terms. Now we have found out the value of P1, delta 1, P2 and delta 2, and we have also found out the value of delta. Delta is given by 1 minus summation L1 plus summation L2. Summation L1 will be given by this expression, summation L2 will be given by this expression. When we substitute all these values in the given formula, x5 by x1 is equal to P1 delta 1 plus P2 delta 2 divided by delta. Now we substitute all the values which we have found out. Then the overall gain will be given by x5 is equal to given by this expression. I hope you understand how we can find out the overall gain with the help of Mason's gain formula.